Welcome to our Brown Bag series, brought to you by HeadHunt in partnership with NUS Institute of Systems Science. Broadcasting live from ISS, we have with us Mr. Edgar Tai, Graduate Recruitment Manager, who will be sharing with us on ISS and their programs. I will now pass the time to Edgar. Edgar, over to you.
Thank you, Tammy. Hi, everyone. Good afternoon. I'm Edgar from NUS Institute of System Science, ISS. Thank you once again for joining us in this series of talks. Before we get to the main topic itself on real-time video analytics, I'm going to share with you, I'll take about 10 minutes to share with you about the stackable program pathways here at NUS-ISS. For those of you who joined us yesterday, and for those of you who are going to join us tomorrow, please bear with me. But this is really going to be interesting for you because the programs that we offer in the stackable pathway is one of the few programs in Singapore that's truly stackable, and that gives you a lot of control and flexibility, okay, with your time commitment. Okay, so let me share my screen. Okay, so NUS, so let's start with a little bit about ISS first. So ISS, we were founded in 1981. So we're exactly 40 this year. So we're part of NUS, and as you know, NUS is the #1 university in Asia, and it has consistently ranked among the best universities in the world. All right, so NUS-ISS is a continuing education institute. This means that we don't offer undergraduate programs. Essentially, we're offering continuing education programs, short courses, graduate diplomas, master's degrees. We're also very focused on practice-based education. That means that whatever you learn here, you can actually apply. And NUS-ISS has been a pioneer in alternative education pathways, and the stackable route is one of those very key initiatives. So if we take a look at what it means that, you know, for a typical master's program or graduate diploma program, there are certain entry requirements, right? And for most institutes, if you don't meet the entry requirements, you don't get to enter the program. But here at NUS-ISS, rather than, you know, if you don't meet certain entry requirements, then we've designed modular courses, certificates, where you can take these certificates on modular courses, and then they eventually stack up, and they get you to a master's degree or even a graduate diploma. So today, I'm just going to quickly share with you, okay, what does it mean by a stackable pathway? How does it actually stack up to a full master's degree? And of course, let you know about some of the subsidies that we offer, and that goes up to 40% of the course fees. So lingo first, you need to understand what are graduate certificates. So here, in short, we call it grad certs. So grad certs are made up of certain modules, okay, or courses. And these grad certs, after you completed a certain number of courses, you get a grad cert. So after you finish a few grad certs, it stacks up to a master's degree or graduate diploma. Okay, so and each grad cert actually addresses a certain job role. So when you take up the grad cert, you will really get to apply the skills that you learn, that you pick up to fulfill certain job requirements. And that's really interesting. So here at NUS-ISS, the grad certs, we also recognize prior learning. So if you do have some relevant experience or say a relevant degree, then you can apply to get exemptions. So let's take a look at the grad cert structure first. First things first, don't really have to be bothered about the words. You look at the diagram. Okay, so like I mentioned, the grad certs consist of certain courses, a certain number of courses. Each course is a few days. Okay, so after you've taken the course, then of course we want you to practice. So as with just as with cooking, for example, okay, you cook a dish once doesn't make you a chef. So you practice many times before you become an expert at the dish. So similarly, we want you to be able to practice. So you'll be practicing it at your workplace, all right, or at home. Then at the end of it, there will be a practice module exam. So once you have completed the courses, you have done your own practice, and you have passed the exam, then you get the grad cert. So after you finish the grad cert, a few grad certs, then you get your master's degree. So today's topic, I'll give you an example. We're talking about the Masters of Technology in Intelligence Systems. That's what's relevant to today's topic on real-time video analytics. So this is the full course structure. So as you can see, the ones in brown, okay, they are grad certificates that are foundation, so they're mandatory. Okay, so you have to take these two foundational graduate certificates, grad certs. The ones on the right in blue, those are the specialist grad certs. So out of 4 specialist grad certs, you choose 2. Okay, so as long as you complete it, then you will have an opportunity to go on to the capstone project. So when you finish the capstone project, then you will finish off your master's degree. So today's topic on real-time video analytics is actually from the grad cert that is intelligent sensing systems. It's one of the specialist grad certs. Okay, so full-time True Train students, if you sign up directly for a master's degree here and you do it full-time, you get to complete it in 1 year. That's the shortest time frame. For part-time students, they take about 2 years because you are working. And then if you choose the stackable pathway, that means that you take certain courses on your own in your own time. Okay, then as long as you finish up one grad cert, you have up to 7 years to finish the rest of the certificates and for you to finish up your capstone and eventually graduate with a master's degree. So that really gives you a lot of flexibility in terms of time commitment. So other than the intelligence systems one, which is very much related to artificial intelligence, we also offer data science masters. Yeah, so this is the intelligence systems one that we saw just now. And then smart systems and platforms, which ultimately stacks up to a master's of technology in software engineering. Okay, so when you do the grad certs, after you've completed all of them, if you have a minimum cap of 3.0, then you will be matriculated as a full NUS student. You finish off the capstone, then you get your master's degree. But halfway through, if let's say you are doing very well with the grad certs, you can also matriculate. You don't have to finish all the grad certs. You can come in as a master's student, but you need to fulfill certain entry requirements first. Yeah. And if you don't actually, then we will recommend that you carry on with this stackable pathway to improve your grades and eventually come in to finish off the masters. So there's a very common question that they always ask us, and that is the stackable route right for me? So this is a common question that a lot of prospective students ask us. There really isn't a right or wrong route. These are just alternative pathways. So here at NUS-ISS, the idea is that we want to be able to open up to as many students as possible who wish to pick up new skills, to upskill themselves. I think that is really important. Yet at the same time, we also want to uphold the bar that NUS has in terms of its ranking. So that's the reason why we want you to come in, but you will have to work hard to be able to finish off the various courses and to graduate. Yeah, so the whole idea is to keep on practicing. So people have also said, yes, I prefer the True Train pathway. Yeah, we do understand that people have different entry points. So the stackable pathway, like I mentioned, allows for a lot of inclusivity. And at the end of the day, you still get the same degree, okay, the same certificates that NUS offers. It all has the NUS stamp on it as well. Yeah, so the recognition is important, but you will have to work hard to complete the courses. Okay, so the last bit from me is about subsidies. So Singapore citizens, you get up to 40% if you sign up for a full grad cert. So this is something that we all encourage you to try because this is really a very good subsidy, 40%. If you are PR, you get 20%. International students pay full fees. Okay, so that's it for me. Yeah, that's it for me. So I'll hand the time back to, at the end of the whole topic, the main topic, I will come back with some Q&A. So I'll hand the time back to Tammy.
Thank you, Edgar. We will now continue with our brown bag session on real-time video analytics brought to you by Dr. Tian Jing from ISS. Now, before I hand over the time to our speaker, please note that there is a Q&A function at the bottom of your screen. So please feel free to type in your questions at any time during the presentation. Please also note that we will be conducting our feedback poll at the end of the session. Without further ado, I'll now pass the time to Dr. Tian. Dr. Tian, over to you.
Thank you, Demi, for introductions. Hello, everyone. My name is Tian Jing. Thank you for spending a long time with us to attend our organized talk. So in the next 15 minutes, I will share with you is very interesting topics. The title is Intelligent Sensing Systems, Real-Time Video Analytics. So now let me share the screen. As you can see from the title of my presentations, so today we are trying to study how to analyze video data and more importantly, in a real-time manner. Okay. We can see many successful applications of video analytics in many different areas. One of the typical application of such technologies can be provided as a photo from my slides. You can see this photo is taken by some CCTV videos, which is captured by the camera mounted outside the restaurant. From the photo, we can see there are 3 people. They are waiting outside for their lunch, but they also queue nicely. They follow the social distancing rules because we can see there are some distance between each of them. Suppose we are the restaurant owners or facility management. With the help of such real-time video analytics solutions, we are able to count how many customers are waiting outside. If it exceeds our capacities for serving the customers, then we might encourage them to come back again for tomorrow. Also, we can do this social distancing monitoring to make sure all the customers follow the social distancing rules. We will relook this case study at the end of this talk to summarize what we learned from this talk. Before we share more technical details, let me say a few words about myself in the next one slide. So for myself, I'm specialized in computer vision and video analytics. So I'm interested to analyze vision data. So where's vision data? The vision data can come from our public surveillance CCTV cameras. Also, the vision data can come from our recorded from smartphones. Also today, all of you are watching the live show of our talk, which is live streaming from ISS Classroom. This is another application of live video data. So video data, analyzing the video data is very important in many different industry sectors. As you can see from my current slides, I list down 14 major industry sectors which can successfully apply computer vision technologies to analyze vision data. For example, in the surveillance sectors, we are able to develop many different intelligent video analytics security solutions. In semiconductor areas, we can apply computer vision techniques to analyze machine defect to help us measure the product qualities. In healthcare, we can use computer vision techniques to analyze many different types of medical imaging device and also help us to make sure the patient monitor patient movement to see how well they can move. In financial service, we can apply computer vision techniques to use facial recognition to do the payment. So we don't need to key in the password anymore. So in ISS, I'm taking care, this is graduate certificate in intelligent sensing systems. This is one of the specialist graduate certificate. It belongs to the Master of Technology in Intelligent Sensing Systems. Okay. So if you are the part-time true train students, so this will be your year 2 elective topics. If you are the stackable students with us, it depends on when you select this elective specialist certificate. Okay. So inside the certificate, it has all these 3 different courses. But all these 3 courses, they are integrated together to address the same fundamental question, which is in computer vision areas. But they address different computer vision tasks. Let me briefly introduce all these courses one by one. Okay. So first, we have vision system course. In the vision system course, we focus on 2D image analytics. So as you can see from the interesting demo in my current slides, we can analyze the traffic photo, which is captured by the camera, which is mounted on outdoor. Then based on the photo, we can automatically detect the object, so-called moving object. We also can recognize the type of moving object, whether it's a pedestrian, bicycle, motorcycle, car, public bus, or taxi. So this related to the vision systems. The second course is spatial reasoning from sensor data course. In this course, we focus on 3D computer visions. This is very important for the robotic systems or autonomous system drivings. You can imagine we are sitting inside this autonomous driving car. Then before our car, there is another two additional cars. One is a black color, the other one is a white color. You can see from the demonstration in my middle region of my slide scheme. So we need to infer the distance between that car and our cars. Based on this distance, we can make different decisions. So whether we need to follow that black car nicely, or whether I need to change the lane to speed up a little bit to bypass the black cars. So all this need to be addressed using the 3D computer vision techniques. The last course is real-time audio-visual sensing and sense making. So basically, we analyze the video data in real time. At the same time, we apply audio data as a complementary information to help us to do a better sense-making task from both audio data and vision data together. Okay. So from the slide, you can see all these three courses, although they address different tasks and topics, but they share the same focus. The focus is in computer vision. So the next question is, what is computer vision? I will give you a nice definition of the computer vision in my current slides. Okay. According to the AI pioneers, the Stanford professor Li Feifei, in her TED talk, she gave a very nice definition on computer vision. According to her definitions, computer vision is defined as a subset of mainstream artificial intelligence that deal with the science of making computer or machines to analyze and understand the image. So basically, we want to teach the machine to see just like at how the human look at the photos. So they can help us to naming the object. That means we can recognize different types of objects, whether it's a laptop, handphone, screen, camera, table, or chairs. They also can help us identify people. That means recognize the people identities. So I'm Tian Jing, so she is a Demi, so we also have Clay as Edgar. We are able to recognize different identity through by facial recognitions. We also can infer the 3D geometry of things. So just I already give an example, infer the distance between two different cars, so that can help us to make decision for the autonomous driving. Also, another example is in robotic system, I can infer the distance between the apple and the robot arm, so I can adjust the robot arm to capture the apple from the table. We also can understand the relation, emotion, action, and the intention in the photo. So for me, I try to use some simple gesture to help me elaborate more about the concept. Then for you, if I'm able to see your face through by the Zoom, I can see your facial expressions, whether you are interested in this talk, whether you are surprised by all the powerful performance achieved by the different computer vision technology. So in summary, computer vision can help us automate the human decision-making process. So if you look at the example shown in the bottom part as my slides, so given a photo, which is a nice lady, as a human, we use our eyes to look at the scene, take the data, then we use the human brain to analyze the photo. So every people carry two cameras, which is two eyes of human. Okay. So similarly, as the computer vision techniques, we use a camera to capture data from the scene. Then after that, we run the computer vision algorithm in the computer to automatically analyze the photo contents. Because photo is very rich in terms of information. So that very famous scene, which is shown in my right side, my slides, one look is worth 1,000 words. So it's very rich. So we need to try to study how to use computer vision techniques to study further, to explore more information from input image. Okay. We can see the computer vision application in our daily life. Okay. For example, in Singapore, according to the news, okay, we need to deploy additional 200,000 cameras in this small red dot. in Singapore, for every 1,000 people, we have 15 cameras. I refer to the public surveillance camera, such as the camera inside the MRT platform, such as the camera inside HDB lift, look at the loan shark. Then in our current ISS classroom, when I do this talk, I think at least 1, 2, 3, at least 3 cameras look at me. Also, you can see from the photo in my slides, this photo is taken from the highway in the east part of Singapore. There are a few cameras which are mounted on smart lampposts. So based on all these cameras, we are able to monitor traffic flow to see whether this road is crowded or not crowded. Then we can adjust our traffic rule. Then we also can adjust our surcharge for the highways. Okay. So far, I give you some introduction to share with you what is the definition of the computer vision. It can be a successful application in many different applications. So the next question, how to do that? Things very interesting and useful, like how to develop a computer vision system. Okay. So my agenda for my following presentation is, I will start with the typical computer vision system pipeline. I will share with you how to build a typical computer vision pipeline. After that, we'll move on to share a little bit more advanced topics, which is the video analytics, which is also the focus of our today's presentations. Okay. So let's start with a general computer vision pipeline first. So in my current slide, I show you a typical computer vision pipeline. It's a sequential pipeline. I will explain all the steps one by one. Okay. So let's look at first step. The first step is acquisitions. We need to perform data collection to acquire the data. Without the data, we cannot analyze anything, right? But in the computer vision area, there are many types, different types of data we can be captured with the help of different cameras. For example, we can use RGB camera to take a natural image. RGB camera is very popular in your smartphone. Also in some smartphones, we have more than one RGB camera. We also have infrared camera, which can help us to collect the photo in the night vision. It's very useful in the night vision, particularly when you take a nice photo in Singapore River in the evening. Okay. We also have the depth camera, which can help us capture the distance information between the object and the camera. We also have a thermal camera, which can help us measure the temperature of the human temperature. We can see many thermal cameras at the entrance of the restaurant or shopping mall. Although now we don't need to take body temperature anymore, we already see such device deployed as entrance of the shopping mall. We also can collect some data for the video data, such as human action and activity, walking, running, lying down. Okay. So in summary, this is some typical data which can be captured in the area of the computer vision. In the image, we have ImageNet. Okay, it provides 1,000 category of different categories. Then the video, we have ActivityNet, which the data contains typical human actions. So this is the first step. We can collect some data. So now data is ready for us to analyze. Okay. But before we analyze the data, okay, we need to process the image quality, because the data quality might not be good enough for us to analyze. For example, in the night visions, you take RGB photo, it is so dark, you cannot see the object, cannot see the beautiful fireworks in the sky. Okay, so we need to enhance the image quality. Another example is you use handphone, record a video, then somehow your hand is shaking, your hand is shaking, so the video is very blurred. So you need to do the deburring to make the photo is clear. So this is the pre-processing steps. We need to pre-process image quality to improve the quality so it can be helpful for us to analyze content in the next following steps. Okay. Next step is feature representations. Feature representation is to try to extract those features from image content to help us the following machine learning tasks. Because usually we don't use the image data raw value directly. Why? The reason is the image color raw value is usually affected by the lighting. So today now there is two very strong external light shooting at my face. If I turn off the lights, then maybe the picture will show differently in the zoom. So you see the color is can be affected by the external lighting source. Okay. So that's why we need to extract the features to perform the analytic tasks. So what kind of feature can be used? So the feature extraction can be designed by the human based on the domain knowledge. For example, if we want to differentiate Coca-Cola and Pepsi, then we can use color as a feature. Red color is Coca-Cola, blue color is Pepsi. If we want to differentiate the 2-liter package of Coca-Cola and the 300 ml package of the canned drink, we can use the shape. So, if the longer shape is 2-liter package, then the shorter shape would be the smaller canned drink. If we want to differentiate the twin package, Christmas promotion package, or those regular package without additional promotion information printed on the package, we can use some texture, because texture can help us what is the information picture printed on this package. Then certainly, we also can rely on the powerful neural networks techniques to help us to learn the features from the data set. Usually, they can learn more powerful features. It's more powerful than those handcraft features designed by the human. So based on all these extracted features, we can move further to do different types of computer vision tasks. So in my slides here, I show you the 3 typical level of computer vision tasks: recognition, detection, segmentation. So these 3 perform different level of understanding of image data. First is recognition. Recognition is to provide image level analytic tasks. That means we need to assign a single label for the whole image, whether it's a laptop, phone, indoor, outdoor, classroom, stadium, is image level, a same label assigned for the whole image. The second level understanding is detection. Detection is looks at a little bit more details to assign a label on different location of the block. So that means I can see 2 people in the photo, but where are these 2 people? The first people could be sitting on this region, row 2, column 2. Then another people could be sitting at the row 20, column 30. So this basically is a block level analytics. The last task is segmentation. Segmentation gives us more details of the analytics task. Basically, it gives us a label for every pixel location. For example, I carry my phone, board the public bus, and somehow I drop my phone. Then there's a crack on my phone screen. So we can use computer vision techniques to tell me, hey, where is a crack on my phone screen? How big is the crack? Then based on that, I can make some claim from inference. Okay. So in summary, recognition, detection, segmentation is the 3 level different computation tasks to give us image level, block level, pixel levels analytics. Lastly, based on all these analytic tasks, we need to make some decisions. Here, the decision I refer to those business decisions. Without the business decision, the analytic task cannot create impaired value to our practical solutions. So what would be the example of the business decisions? I'll give you some examples. Okay. First example, if you look at the photo, the photo at the right side in my current slide, you can see this photo is captured from some outdoor shopping street, for example, the Ultra Road. So the first business decision is what kind of object you can see from the photo. Is it a pedestrian? Is it a bus? Is it a car? Suppose you see more pedestrian from this shopping street in weekend, then you might want to adjust your rule to allocate these shopping streets is only allowed for pedestrian on weekend to promote your shopping and retail sectors. Okay, so it's the first example. Another example is you look at the yellow colored arrow shown in my current photo, the photos. You can see all the cars they follow. We are able to detect the car, then analyze their trajectory, their movement. So if we look at all these yellow color arrows, what would be the major direction of all these car movement? Is it straight, left turn, right turn? Which direction tends to be more traffic jam? Then based on that, we can adjust our traffic management rule or even the traffic lights timing to give us a smooth traveling experience for this shopping street. Okay. So here I give you two examples how to make business decisions based on the analytics result achieved by the computer vision techniques. Okay. So this is a typical computer vision system pipeline. So certainly in practice, we can customize this pipeline based on our target problem statement. In the next 4 slides, okay, I give you some more more information to elaborate a little bit more about the 4 different computer vision tasks. I use this single photo as example to explain the difference between all the different computer vision tasks. The photo is a quite typical movie poster. So the movie title is "You Are the Apple of My Eye." So you can see from the photo that a group of young people, they are sitting together, but certainly they don't follow the social distancing rule because it stays too close to each other. Okay. So I use this photo example to explain. The first task would be recognition. That means what is inside this image? Okay. Is it a human? Is it a sky? Or is it a cloud? Is it a building? Okay, so if we analyze this photo using certain image recognition model, we can realize, oh, actually, it's the people, right? We can see a lot of people inside the image. Okay, so since we know there are a lot of people inside the image, so the next question is where? Where is these people? How many people? Okay, so that's the second computer vision task. We need to detect the human object inside the photo. You can see each individual human object is labeled by this green color, the bounding box. The green bounding box indicate location of the human. So we can simply count the number of the box, so know how many people inside this photo. You also can see some green color bounding box, they have some overlapping because they sit too close to each other. So there's some overlapping for this green color box. Okay. Next, based on the detected humans, I can do more detailed analytics from detected human only. Instead of analyzing the whole image, I can analyze the detected human only. For example, there's a young gentleman in the middle. I can do the age estimation to estimate how old he is. I can do the gender recognition. I also can do the facial expression recognitions. So it's so-called attribute, human attribute recognition from the detected human object only. The last task is recognize the human body temperature, right? So based on body temperature, I can extract the key skeletal key point, the human body. Based on the key point, we can see we can see most people, they are sitting, but there's one lady, she raised up her hand, then another guy, he raised up his leg. So based on body body posture, we can infer what is emotion of all these young people. Okay. So in summary, this is some examples to elaborate more about the different computer vision tasks. Okay. So far, we start with the computer vision's pipeline, then we explain all the computer vision tasks. But from all the example, you can see most the techniques example so far we have discussed can be applied on the single photo directly. Then the question is, hey, where is the video? Because today we talk about video analytics, right? So where's the video? Okay, so we'll move on to the next part to talk about more advanced topic of video analytics. Okay. Before we talk about the video analytic techniques, so let me try to address a very important fundamental questions. What is the benefit and advantage to analyze a video instead of analyzing a photo? So that definitely needs some benefit, right? Otherwise, we don't need to analyze the video, okay? So in this slide, it summarizes the 4 key advantages which is exclusively provided by the video compared with single photo data. Let me go through one by one briefly. The first benefit is see the object motion. Okay. So video is considered as a sequence of image, such as you record a video, every second you record 20 frames. So with help of this image sequence, I'm able to see the object motion inside. If you look at the top right example on my slides, a single photo, you only can see some black color dot. But with the help of these animations, this animation displays is a set of photo continuously. We're able to see it looks like there's a human who is working nicely. Okay. Another example is you can see some car, you can see a lot of car from the surveillance image captured by traffic cameras. But if we see so many cars in a single photo, it doesn't mean the place is jammed. So in other words, if we see a lot of cars, it only means it's crowded. It's crowded, it doesn't mean it's jammed. So with the help of multiple images, we can measure the speed, the movement speed of different cars. If we see a lot of cars, but all of them moving very fast, so it's crowded, but it's not jammed. However, if we see a lot of cars, but all of them are moving very slowly or even not moving, that means this place is jammed. So in summary, based on the object motion, we are able to differentiate crowded place and a jammed place. So it's the first benefit. The second benefit is see the scene change over the time. If you look at the bottom left, the two photos shared in my current slide, for each individual photo, you can see a gentleman and a luggage. But based on the single photo only, you are not quite sure whether the luggage belongs to the gentleman or not. But comparing these two photos, we can realize as the first photo, this gentleman stands very close to this luggage. Then somehow, after a while, this gentleman walk away and try to leave from his luggage. That means this luggage is considered as abandoned luggage because it belongs to this gentleman, but this gentleman walks away. Okay. So why we are interested in abandoned luggage? Because abandoned luggage is very serious security concern in the security sector. So maybe it's something abnormal inside the luggage. Okay. So in summary, with the help of multiple images, which in the video, we are able to differentiate and identify whether a luggage is abandoned or not abandoned. Okay. The third benefit will be track object trajectory. Okay. You can see it from the bottom right photo showing in my slides. Okay. Based on the photo, you can see a lot of different cars. The motion trajectory are indicated by red color arrows. It looks very messy. It looks very, if you just look at the red color arrow, it looks very messy. That means this place, you might want to add an additional traffic light to help you to manage these traffic conditions. The last benefit will be recognize the event. Example would be if you see a lot of photo in the, if you see a lot of human in the photo, but you are not sure whether it's classroom, whether it's stadium. If you see a lot of photo, nobody is working, nobody is moving, that means it's in meeting. But if you see some people, they are walking around, most people, they are sitting down, maybe this is a classroom. But if you see a lot of people, all of them are more around, then they are doing some exercise in the gyms. So this is a summary. These are four fundamental benefits provided by the video. We are able to analyze the motion which provide the videos. However, due to these four fundamental benefits introduced by video, is also introduced as additional challenge, how to analyze the motion, because motion is exclusively in the video, it's not providing the image. Okay. So in my following slides, we'll talk about the different steps to analyze the video. So we start with motion estimations. Step one is motion estimation. Step two is track the object based on motion across multiple frames. And step three is based on the motion and the track object, we can analyze action and event from video. So this is my storyline for the following slides. Let's look at the motion first. Okay. So what is the motion estimations? So motion estimation is to give us a motion vector which can describe the displacement at the pixel location between two photos. One photo is so-called a reference photo, another photo is so-called a target photo. So what does this displacement mean? The displacement, it just means the position change due to the object motion. Okay. First photo, you can see my hand on this row 2, column 2. The second photo, you can see my hand move to another position, row 5, column 6. then the displacement in terms of row is 5 minus 2, which is 3. And in terms of the column coordinate, which is 6 minus 2, which is 4. So the displacement indicates object motions. Also, based on the displacement, we can know whether the motion is large motion or small motions. Also, the displacement can tell us direction of the motion, whether I move to the right side or whether I move to the left side. So you can see there are a lot of rich information provided by the motion vector. But how to get the motion vectors? How to get the motion vector? So motion vector can be generally calculated by the different techniques, which is the frame level motion estimation, block level motion estimation, pixel level motion estimation. These a few words sound very familiar, right? Because just now I already mentioned to you in the image analytics, which is the 3-level image analytics. Image level analytics, block level analytics, pixel level analytics. So we have the same mindset when we analyze the motion. We have frame-based motion, block-based motion, and pixel-based motion. Okay. For frame-based, we can estimate a single motion vector for the whole image. For block-based, I will split the image into the different blocks. Then for every block, I will estimate the motion vector. Then for the pixel-based motion estimation, we apply the operative law to tell us the motion vector at every individual pixel locations. So it's a 3 levels of different motion estimation, which is consistent with our concept analyzing the image. Okay, after we get the motion, how to track the object? With the help of the motion, we are able to track the object continuously for the multiple frames. So object tracking is very active research areas. Okay, so in my current slide, I show the major milestone works in these object trackings. You can see there are 2 different categories. Go to the right side in my slide, which is deep learning. Go to the left side of my slides, which is the correlation based. Okay. You can see some methods are highlighted using the red box, because for those methods highlighted in the red box, we study more details in our class. We also study that in our in-class workshop. Because usually when we conduct the MTech course, we have lecture, we also have workshop. So we study more details for those selected milestone works. So today, let me give you one example, just one example, to share with you a typical object tracking frameworks, which is one of the major frameworks we use, very widely used now, which is so-called a deep sort. Deep sort stands for deep learning based simple online real-time tracking. Okay, so the deep sort will separate this tracking into 2 sub-problems. First one, detection. Second one, associations. So what does that mean? Okay. So from my slide, you can see the top row, the first row. The first row, I show 3 pictures. I can apply deep learning-based detection model to detect individual human at every individual frames. So all those detected human are highlighted using the red box. So this is just a detection for individual frame. Then the next step is associations. That means I need to link and associate object across multiple frames. So for frame 1, I have object ABC. For frame 2, I have another object ABC. But object A in frame 1, it doesn't mean object A in frame 2, right? So we need to associate and link all these objects together. But how to link them? So we based on different rules. For example, we can based on the appearance-based feature similarity. I can compare 2 objects. If they wear the same similar color jacket, then maybe they belong to the same person. Second rule would be displacement-based. If the 2 objects they stand too close to each other across multi-frame, then it's more likely to be a same person. Next one, we have motion model-based. That means based on the historical trajectory for each human, I can make prediction. If I predict this human, he moved towards the right side, then at frame 2, the object at his right side might be more likely to be the same person. Okay. So these are some general rules. After we apply such association rules, we are able to link multiple objects across multiple frames together, which is shown in my second row in second row in my slides. You can see for each individual object, I use different color to indicate. I have a green color box, so which consistent show the same percent across multiple frames. We also have orange color, which are another people. Then we also have blue color, which are another people. So this gives you some examples how to associate different objects which are calculated and detected from each individual frames. But in our class, we'll share you more details about the algorithms. Okay. So far, we talked about the motion estimation and the tracking. We estimate the motion, we track the motion. But what's the next step? Next step, we analyze motion, right? Analyze motion so we can recognize the human actions. Okay. So here we'll talk about the 3 different understanding of the human action from the video. We have action, activity, and the event. So action is the shortest duration in terms of time. For example, just a few seconds. Activity is slightly longer. For example, a few minutes. Event would be the longest concept among all the 3 concepts, such as a few hours. So what be the action? Action is now I'm sitting down in front of the camera, I raise up the hand, move the hand. This is action. So what's the activity? Activity is a sequence action. So I raise up the hand, say hello, and then this is the sequence action. So now I'm doing the lecture, I'm doing the teaching activity. Then for the event, you see actually our event lasts 1.5 hours for today. So this is our event. Okay. From the animation showing in my current slide, you can see some examples about the human action recognition. You can see all this animation is a small duration of the video clip. You can see some guy who is doing the exercise in boxing. Some lady is doing the making up. Then some young children, they are celebrating the birthday parties. Okay, so these are some examples of the human action recognition from a very short video clip. Okay. So in the next few slides, we'll be focused on the action recognition, which is the fundamental, the level 1 understanding of video event. So the objective of action recognition is given an input video clip. It's not image anymore, it's a video clip. Then we need to perform some analytic tasks, then output the action label for the whole video clip. Okay, a single action label for the whole video clip. Action recognition is not a new concept. It's not a very totally new concept. Actually, in year 1878, which is 150 years ago, humans already show some understanding for the action recognition and applies techniques to generate some product and solutions. So you can see from the slides. Okay, in the slides, at the left side, I show some pictures. In the picture, there's one gentleman who is riding the horse, but if you look at the picture carefully, you realize the horse, the 4-legged horse, has a different posture. If I display all this picture continuously as an animation, which is the right side, you can see, oh, actually it's a young gentleman who is riding the horse. Okay. So from here, we already can see the fundamentals concept of how the human look at the activity. Actually, we look at the posture, we look at the motion. Actually, we don't look at the appearance. We don't care whether it's a black color horse, white color horse, brown color horse. We also don't care whether it's a gentleman or whether it's a lady, but it's a horse riding, right? So it's already show us, as a human, we use the motion and the posture to recognize action and emotions. Okay. So action recognition is another very active areas in computer vision. So every year we have many different milestone works. Okay. So in our class, I summarize the major milestone works into different categories. So there are 2 very big categories in the first column in my slides. Okay. So we have non-deep learning based representation and the deep learning based representations. If you look at the first category, the first 2 rows in my slides, the non-deep learnings, we also can further classify them into the sparse feature and the dense feature. So both of them share the same idea to analyze the motion features. But how to get the motion feature? Motion could be sparse, motion could be dense, depends on where you get the motion. If you get the motion from every pixel location, which is the dense. If you only get the motion from a strategy location from image, which is sparse. So depends on how you use, depends on how you get the motion. The second category you can see is the very big table in my current slide is a deep learning based representation. We also can further classify into the single stream, two stream, 3D CEM. I will briefly mention these are 3 representative works for today in the next 3 slides. First one, frame-based CEM. So the frame-based CEM, the key idea is to borrow those very powerful convolutionary neural networks which already achieved from a static photo, but how to extend this concept, apply on the video sequence with the set of photos. So the input is the video clip, but output is the single action labels. So I can apply this convolutionary neural network CEM on every frame, but at the end, we still need to combine all of them together to make a single final decision, which is action label. So we cannot say, oh, frame 1, this guy is working, frame 2, this guy is running, so he's wrong. So we need to have the same one label for the whole video clip. That means we need to address how to combine the decision from different frames together, because different frame might give you a different decision. So to address this question, how to combine decision from different frames, so we have 2 different approaches, so-called early fusion and late fusion, which are shown in my current slide. For early fusion, that means we do the combination and fusion earlier. So how early is early? So we just combine all the frames together. Okay, so the one frame can be represented in as a dimension of h times w. H means how high is the image, w means how wide is the image. For the color frame, I have 3 channels. Grayscale, I have 1 channel. If I have a T frame, such as 10 frame, I need to further multiply T. I can combine all the frames together to be a very big multiple channel array. So the dimension is T times 3 times H times W. After that, I apply convolutionary neural networks. This is so-called early fusion. Make the fusion earlier. Okay. So on the other hand, we have another approach so-called late fusion. Late fusion means we late fusion at a later stage. So that means for every single frame, we apply the convolution neural networks. After that, we need to apply some space-time pooling and fusion to combine them together. This is so-called late fusion. So, but both these two share the same idea, is directly apply those 2D convolutional neural networks, which should achieve from an image on each individual frame of video. Okay. Now you might be curious, okay, where is the motion? Because now I emphasize motion is very important, but now somehow this method doesn't use any motion, right? So that's the idea of my second approach. Okay, since motion is very important, and on the other hand, the image is also very powerful. So how about we combine these 2 ideas together? This is so-called a 2-stream framework. So I have 1 stream, look at the frame only. We can apply those 2D so-called convolutionary neural networks only. Then another part is so-called the temporal information, temporal stream. I explicitly estimate the motion from the video clip. I will treat my motion information as a new image. It's not the image with the color anymore. It's the image with the motion, right? The data value is be motion values. I will treat it as a new image. I apply convolutionary neural networks. Then after that, I will combine it together. But the key idea is to combine both single frame and those motion estimation information frame. That's why we call it a 2-stream, spatial and a temporal. So you can see there's a very explicit motion estimation steps. Okay. Then from here you can see motion is quite useful. Then how about to perform the same motion estimation, but I don't want to have the explicit motion estimation. Yes, we are also able to do that. So we are combine both motion estimation, so-called the temporal stream and the spatial stream together, will perform a joint space-time convolution together, which is so-called the 3D convolution. With the help of the 3D convolution, I'm still able to estimate the motion informations, but I don't have the additional explicit motion estimation steps. I will integrate all the steps together into one framework. This is so-called a 3D convolution. Okay, so we'll mention more details in our class, because all these slides are our actual slides we use in the MTech class. Okay, so far this is my second part. So we talk about video analytics. We start with estimate the motion, track the object across frame, then analyze the motion. So finally, let's relook this social distancing case study. So we use this case study to summarize what we have learned from today's topics. Also, we can see it's a very nice study to cover all the 3 courses in this intelligent sensing system graduate certificate. So what is social distancing? Social distancing is very popular application now. Before the COVID-19, there's no such technology. Because nobody cares social distancing, but now everybody cares. Okay, so we have many different social distancing solutions available in the market. But the example shown in my current slide is developed by the Landing.ai. So the demonstration video is provided from the YouTube. So you can go to YouTube to look at that demonstration video. Okay. So from the photo, you can see this is a video captured by the camera. The camera is mounted outdoor at some shopping street. Okay, so for the objective of the social distancing is to monitor the social distancing between human and human, right? So it's human and human. We don't care the human and the bicycle. We don't care the human and the rubbish bin. So we care the distance between human and human. So that's why we need to detect all the human from the video. This is so-called the object detection. So we will study this in vision system course, which is the first course in this graduate certificate. Second, the objective of social distancing is to find out the distance, which is in terms of the physical distance, such as 1 meter, 2 meters. We don't care the digital distance, such as 10 pixels or 20 pixels. Why? The reason is if you stand very near to the camera, the 10 pixel distance between 2 people might be very short physical distance. However, if you stand very far from the camera, the same 10 pixel distance between the human might be very long distance. This is due to the camera view. So therefore, we need some technology to help us to convert this is the digital distance from image to be some physical distance. To address this question, we need to apply the camera modeling, geometric modeling to help us to convert from CCTV view to be the bird eye view, which is in the middle part in my current slides. Then from the bird eye view, I can infer the physical distance between objects. So this is related to our second course, spatial reasoning from sensor data. We need to address the 3D computer vision question. Okay. Lastly, for the social distancing of solutions, we need to monitor the human continuously. Continuously, we cannot say that frame 1 or this guy is good, then frame 2 this guy is bad, he doesn't follow the rule. We need to monitor this is the human continuous across the frame. So that needs to be addressed using the tracking. So for tracking, we study in real-time audio visual sensing and system course. Okay. So in summary, I think this is a very nice study to summarize all the topic we learned today. Also is very related to the intelligent sensing system graduate certificate. This is a part of the Master of Technology in Intelligent System program. Okay. I think that's all for my presentation today. I hope you enjoy our talk with your lunch together. Okay. If you have any question, you can post a question in Q&A sessions. Then you also can contact me through the email offline. This is the email showing my size. Okay, thank you very much. So now I pause time to the demo. Okay, now I look at the Q&A session. Okay, let me look at the question. There's one question. He record the video. The woman in the white has the ID, and when he passed the man in brown, her ID was given to the brown man. Okay, I think your question related to the case study, the social distancing case study in my last slides. Okay, actually, you are very sharp. You notice the difference, so-called the ID shift. This is so-called ID shift from the lady to this brown man. So this is due to the error in the tracking. That means the tracking algorithm inside the case study is not correct to maintain the same ID. Okay, so we will acknowledge this is the limitation of tracking for that demonstration only. So, but we are able to address this to consider this ID shift and change problem in the tracking. Okay, thank you for the question. Okay, there's a next question. What are the some considerations for a video analytics platform computing power VA algorithm? Okay, this is a very good question. Okay, this refers to the deployment. That means how you deploy your video analytics solutions into the practical system. Okay, you can deploy it in different ways. For example, in cloud-based architect, you have some centralized server. You can stream back all the video back to your centralized servers. Then you also can deploy it into some edge computing structure. That means you have some small intelligent edge computing, such as the JSON Nano, or the Intel Neural Compute State, or the different edge computing device. Okay, it depends on what in architect you deploy a solution. Okay, then if you refer to what is the consideration of such hardware, I would say it depends on your problem statement. So the functionality provided by this project. Okay, so we need to evaluate whether we are able to run all the video analytics algorithm in real time. Okay, so based on that, we can calculate what is the computing powers. For all the video analytics algorithm, we are able to calculate is the computational source, and we are also able to evaluate the frame rate. That means how fast we can process all the frame in real time. Also, don't forget, we might not need to analyze all the video in real time. Otherwise, that would be a very huge requirement for the hardware requirement. For example, you are the facility manager. Okay, in your shopping mall, you have 200 cameras. Every camera will give you the real-time video. You might not need to analyze all the 200 cameras in real time. Okay, so you can based on the problem statement, you can decide what be the strategic camera feed so that you can analyze this important camera feed in real time. For those not very important, maybe you can run this in a snapshot mode. That means for every second you take one snapshot, you analyze this video. Okay, this depends on your problem statement in your specific projects. Okay, but I think this is a good question. Okay, it's regarding the implementation of video analytics. Okay. Next question, can a few cameras connected together for video analytics? Okay, yes, the answer is yes. Okay, again, it depends on how you combine all the multiple cameras together. Okay, I'll give you two typical ideas. First ideas, you have a shopping mall. Okay, level 1, you have supermarket. Level 2, you have restaurant. Level 4, you have a library. Then each of them has a different camera. All these cameras will stream back the video to your centralized servers. But you want to check this suspicious guy, across multiple cameras from different locations. Then you need to do the person re-identifications to identify whether it's the same person which appears in different locations: supermarket, restaurant, and the library. So it's the first step. This is the first option. Second option is you have two cameras. They are very tight. They are very tight together. It's like a stereo camera. Stereo camera such as Intel RealSense or Microsoft Kinect. You have two cameras. The two cameras capture two photos together. You combine two photos together. You can infer some distance or depth information. So you can combine these two photos before you analyze the video. So these are two different options for you to analyze the multiple data which are provided by the multiple camera. Okay. So this is my suggestion. Okay, next is a very technical question. Okay, how does the deep sort and field mode these two algorithms compare? Okay, This is a very detailed. Okay, I believe you are working in this area. Okay, so deep thought it doesn't mean a single object. So although this S means simple, it doesn't mean single. Simple, it doesn't mean single. So both of them can address a multiple object checkers. Okay, so for different algorithms, we need to look at what is the rule for detection and association as we share in the slides. Detection, I think most of them rely on the detection or deep learning based object detector. Second, association. For association, it really depends on the user to define association rules. We can rely on more on the appearance. If you look at the camera, monitor camera continuously, single camera continuously, okay, they have a more relevant feature in appearance. However, if you want to check your stuff, all the stuff wear the same uniform, then this rule might not work. You need to look at a non-appearance similarity, such as motion, such as trajectory. So association is really a challenge. So you need to study what is the best association rules depends on your specific project. Okay, but I think I can see you are working in this area. Okay, if you are interested, maybe we can get more in our classroom in future if you attend our class. Okay, thank you. Okay, I think this is all the technical question I can address. Okay. So now I pass my time to our colleague Edgar to address those program-based questions. Thank you.
Thank you, Dr. Tian Jing. Okay, so I'm here to answer any of the program-related questions. If you do have any, you can type in the Q&A. Okay, so there's a question on whether you need programming skills to take the class. Dr. Tian Jing, would you like to answer that?
Okay, sure. You can hear me, right? Okay.
Yep.
Okay, good. Okay. There's one question. Do we need a programming skill today? I think for our course, particularly for the topic really for today, definitely we have, because we have in-class workshop. Okay, in-class workshop. Many in-class workshop are programming based, so we need a programming skill to do some development in the class. We also have some non-programming based, so-called case study discussion based, because we are practice-based learning, right? So it's not the programming-based learning. Okay, so we have discussion-based workshop. For example, we will compare different tracking algorithms. We will compare different social distancing rules. We will see. We will compare them some advantage or disadvantage. Okay, so in summary, we need programming skills to attend the class, to do some workshop and assessment. But besides the programming skill, we also need additional knowledge. For example, some domain understanding for these areas. I think all the courses have the prerequisite. You can refer to our website to see what is the prerequisite for each individual course. As long as your prerequisite is you can meet your prerequisite, I think you are always welcome to attend our class. Okay. Thank you, Edgar.
Yep. Okay, thank you, Dr. Tian Jing. So yes, everyone, the idea is that that's why you can see that this particular course that Dr. Tian Jing is talking about is really very much a specialist, is part of the specialist graduate certificate. Yeah, so if you are going to join the class, we will definitely be encouraging you, especially if you are planning to take up the full course. Then and you don't have some of the prerequisites, then you have to start the fundamentals, so it'll be easier, the foundations grad certs. Okay, are there any other questions related to the programs? If not, I'll hand the time back to Tammy.
Thank you, Edgar. Thank you, Edgar. And thank you, Dr. Tian, for your time and for your valuable sharing today. We hope you've enjoyed today's session, and we'll now invite you to participate in our feedback poll. Please give us your honest feedback so that we can further improve on our brown bag series. The feedback poll should be popping up on your screen, so please take a few moments to share with us your observations. Thank you very much for your feedback and for joining us today. This Brown Bag series is proudly brought to you by HeadHunt in partnership with NUS-ISS. Please join us tomorrow on the topic of exposing platform services to front-end and partner services via API from ISS. Please sign up early on our website, masterclass.sg. We look forward to seeing you tomorrow. Bye.